here's how we name organic compounds. We have a system. It's different from any other naming system that we've dealt with in chemistry. Yeah, organic is kind of its own little individual field of chemistry. It's got its own naming system. The reactions occur in organic chemistry that you wouldn't otherwise predict in other forms of chemistry. So here's how we name them. I always identify the longest continuous chain of carbons. That's what I call the parent chain. And anything that's branching off of that is considered functional groups. So here's an example. This is a molecule that has 1, 2, 3, 4, 5 carbons in its longest chain. You can count other ways, 1, 2, 3, 4. That's not long enough. So it looks like 5 carbons is the longest chain. So the root or the parent is called pentane. But then there's a methyl group on the pentane. Not only do we have to say that there's a methyl group on it, we have to say where the methyl group is. So go back to the parent and count carbons from whatever side makes the number the smallest. And in this case, it doesn't matter. 1, 2, 3 carbons into the parent, we have our functional group. So we call this compound 3-methylpentane. The parent always comes at the end. You're always going to find the parent at the end of it with any functional groups identified out there at the beginning. Another thing that I wanted to mention. If we count up the atoms here and we give a chemical formula to this compound, let's take a look at this. How many carbons are in that structure total? 6, so it's C6. How many H's? 14. Does that look familiar? What else would have that formula? Hexane. Hexane. Yeah. But this is not hexane. It's something different. So this is very possible when you have organic chemicals like this, is to have a different number of a different number of compounds that all have the same chemical formula, a different arrangement of atoms. And so that gives us another term to worry about, and that term is isomer. When you have two chemical structures that have the same formula, but they're different, they have a different name and they're a different arrangement of atoms, those are isomers of each other. Okay, so I'm going to give you just some other guidelines for the nomenclature of organic molecules. The nomenclature just represents the system of naming. It's a fancy Latin word, nomenclature, but it just means what is our system that we're going to use. You need to practice this a lot. It may seem really easy. Even in class, you might think, oh, well, that's pretty easy. I got that. But then when you get to doing the homework problems, you start getting tripped up and it's kind of frustrating. Just keep practicing at it. Use the solution manual as a guide. You just need to practice a lot before it starts really coming to you and giving you a level of comfort. So here are some other important things that we'll need to know in order to name organic compounds correctly. I'll give you some examples so that we can use those and see what they really mean. It probably doesn't mean a whole lot yet. Okay with that? All right. So, I'm going to come back to this page. We're going to just try some examples first. All right. So we'll do this first one together, and I have two others that I'll ask you to try. Just try to go systematically about naming these things. The first thing you're always going to do is identify the parent chain. So look for the longest chain of carbons. And this is not going to be difficult because this is not even a carbon, it's a Cl. We'll call that a chloro group, which is weird because we're going to consider that to be a functional group. I think of group as something plural, more than one thing, but there's just one atom. Okay, but still it's what we call it. So 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row, a continuous chain of carbons, that makes that parent octane. Octane, right? And so we also have a functional group on this thing. So we would call this chlorooctane. But it's not just enough to call it chlorooctane. We have to identify where on the octane molecule the chlorine is. So we're going to count, starting with carbon number 1. 1, 2, 3, 4. Looks like the chlorine is in carbon number 4. So we'll call this 4-chlorooctane. Now, when you assign a number, you have to, it's not correct if you don't. You need to minimize the numbers in the, with a functional group. So you would not start with this, and it's possible, sometimes you're going to have functional groups that are over on the right side, and you'll have to start counting from the carbon on the right and count left to number your carbons, and that's fine. That sometimes is going to happen. But in this case, the lowest number is going to mean that carbon number 1 is over there. So this is carbon number 1. So remember, the number is going to tell us where the functional group is on the parent chain. So the name of it would be 4-chloro. No hyphen when we go right to the parent. It's just octane. So the parent always comes last in the name. And any functional groups with where they're at come before. Do you have a question, Neil?
So I was just wondering, so when do we have to count from the right?
If your functional groups are over more toward the right.
Oh.
You want to minimize the numbers on your number. Okay? And let's try this one. Identify the parent and then identify any functional groups that are on there. What do you come up with for a parent? No? No? Anybody else get something other than 7? It's an octane. The parent is octane. So be careful with that, and I did that on purpose. Here's our parent. The longest continuous chain of carbons, Dalton, is right there. There it is. So that means that we have 3 functional groups. Sorry about that. I can't calibrate the whiteboard or smartboard to right where I think I'm writing. But anyway, methyl, methyl, methyl. We've got 3 methyl groups on this thing. Okay? And the parent is in red. It's the octane. Okay? So, now what do we do when we have multiple of the same functional groups? Well, I told you that back here. When you have multiple identical functional groups, like we have 3 methyls, then we're going to have to use tri. It's going to be trimethyl, but you still have to say where they're at. You can't just say trimethyl octane. So we have to give them numbers. So where are those methyls at? If I start counting on the parent chain over here, it's 1, 2, 3, 4, and there's a methyl on the 4th, on the 5th, and on the 6th. It would be 4, 5, 6 trimethyl. But if I start counting over here, the numbers are going to be smaller. So here's carbon number 1, 2. There's a methyl on 3, 4, and 5. So those are smaller numbers. You want the smallest possible numbers on your functional groups. So the correct name of this thing would be 3,4,5 hyphen trimethyl octane. I'll put that in here. I'm not probably going to be able to fit it very well.